To learn more about reflection, click on the reflection box. You experience reflection of light when you look into a mirror. Reflection also occurs when you listen to sounds bouncing off surfaces and when you look directly at your surroundings. Reflected sound might include a police siren or construction sounds from blocks away. Also, if you have ever heard an echo, you were detecting reflected sound waves with your ears. Now think about what you see with your eyes. How many of the things around you are giving off their own light? This computer, any electric lights, and the sun produce light. Most of the other things you see only reflect light. In fact, most reflect only certain wavelengths of light, which is why you see color. This red apple takes in all wavelengths of visible light except the wavelength that your eyes see as red. Red light is reflected off the apple in all directions and into your eyes. A green leaf takes in all wavelengths of light except green. The leaf reflects green wavelengths of light to your eyes. In addition to seeing reflected colors in a mirror, you are also seeing reflection off of two surfaces. First, waves of light from other sources bounce off your face. These reflected light waves then travel to the mirror. Finally, you see the light waves that bounce back off the mirror to your eyes. There is a simple law that describes how any wave will reflect off any surface. You know that sound and light usually travel in straight lines out from a source, such as this flashlight. The law of reflection says that the angle at which a wave strikes a surface equals the angle at which it bounces off. Consider the light waves traveling along the arrow on your screen. To measure the angles of light reaching a surface and the light that is reflected, you need to start with an imaginary line that is perpendicular to the surface. This line is called a normal line. The angle that an incoming light or sound wave makes with the normal line is equal to the angle it makes with the normal line as it reflects off the surface. Notice that both angles are measured from the imaginary normal line. Click on any flashlight to shine it at the mirror. Explore how the beams of these flashlights follow the law of reflection. The angle at which the light waves hit the mirror equals the angle at which they are reflected. Click Continue when you're ready to move on. You know a mirror follows the law of reflection, but why can't you see your face reflected from, say, a wall or most tables? The reason has to do with light reflecting off many different surfaces instead of one smooth surface. A surface that is not completely smooth will have many small flat areas that reflect light. As light waves hit these areas, they each reflect at an angle according to the law of reflection. The light waves are reflected off in different directions instead of all being reflected together. This is the reason that you cannot see a clear reflection off rough surfaces. Often, even things that appear smooth are actually made up of many surfaces facing slightly different directions. Sound waves reflect in a similar way, which is why you can hear an echo in an empty hallway. You would not hear the echo in a hallway filled with people because the sound would reflect off the people in many different directions. Click on the flashlight to shine it at the wall. Notice the reflection of the light waves from the flashlight. Since they bounce off the surface in different directions, your eyes do not see a clear reflection, as you would from a mirror. To learn about the transmission of waves, click on the transmission box.